Hi everyone, today I've got a trig ratio applications question. So Ruka was hiking in the mountains when she spotted an eagle sitting up in a tree. The angle of elevation of her view of the eagle was 35 degrees. She then walked 20 meters towards the tree. From her new position, her angle of elevation was 50 degrees. The distance between the eagle and the ground was 35.5 meters. Let's start drawing in a few key points. So firstly, let's draw in this tree. I've got a tree and it is 35.5 meters. I've got a distance out to Ruka, and let me just draw in Ruka down here. This is going to be Ruka. It says that she was looking from her position up to the top of the tree, and that was 35 degrees angle of elevation, so 35 degrees. It then said that she walked 20 meters, so I'm not going to draw her again, but I'm just going to do a little dash there, and it said that she was looking up at an angle of 50 degrees. And it did say she was walking 20 meters. Last thing that I want to draw is just an extension up here. So if this 35 degrees angle of elevation down here, what that means is that this angle up here is also 35 degrees. And if this 50 degrees down here, it also means that this angle up here, that one that I've just drawn in, is 50 degrees. So let me actually just erase that because it'll start to get a little bit confusing. But the angle, and I'll erase this one as well while I'm here, the angle of this little part here is going to be 50 minus 35, which is 15. So I might just do it on the other side. Let's go on with the pen. 15 degrees is just that angle in there. Okay, we've got everything that we need. This is the ground. This is the top of where the eagle is sitting. Okie dokie. Now, we've just done part A, draw a labeled diagram to represent this information. If Ruka's eyes are located 9 centimeters below the top of her head, calculate how tall she is. Give your answer in meters, correct to the nearest centimeter. So basically, this entire thing here, this tree, is 35.5 meters. I need to figure out what this distance is from here to here. This distance down here. We don't have a value for that yet, and let's just call that x. Okay. We also don't know what this value down here is between Ruka's second location and the tree. Let's call that y. Now, the next thing that's important is if we look at this second triangle, the internal angles of a triangle add up to 180 degrees. So 180 minus 35 minus that other 15 at the top is 130 degrees there. Okay, now if I was to draw just an angle down, or if I was to continue this triangle down there as best as I can, continuing that means that this angle over here is 50 degrees. And if this is a right angle, this is starting to get a little bit complicated, but if this is a right angle down here, if that bit there is a right angle, then the bit that's left is going to be 360 minus 130 minus 50 minus the other 50 minus the 90 is 40. So 40 degrees just in there. That's going to help us a little bit later. Okay, step one. Let's set up an equation of the 35 degree. So I have got always helpful to write. So katoa. And I'm interested in the adjacent side and the opposite side. So I'm going to use toa. So I've got tan of 35 equals the opposite side, which is not actually 35.5 meters, but it is this x over here. Because if we were using the entire length, that doesn't work for the triangle that we're interested in. So we need to use x. So the opposite side is x over the adjacent side is 20 meters, which we will just say is 20 plus y. Okay, let's rearrange this for x. So I'm going to have, if I multiply the 20 plus y up to the other side, I'm going to have 20 plus y times tan 35 equals x. And I'll leave myself a bit of space. Let's set up a second equation. This time let's focus on the tan of 50. So I'm going to have tan of 50 equals, let's go back up, x again because we're interested in the opposite side, x over y this time. X over y. Same thing, let's rearrange this for x. So y times tan 50 equals x. Okay, third step, we've got a system of simultaneous equations here. I've got something equals x up here, something equals x, and down here, something equals x as well. So let's put those two against each other. I've got y tan 50 equals 20 plus y times tan 35. Okay, next line. On the right hand side, we can simplify this down to 20 tan 35 plus y tan 35. On the other side, I'm left with y tan 50. Now let's move this y tan 35 to the other side. So currently it's positive, so we need to turn that into a negative. So y tan of 50 minus y tan of 35 equals 20 tan 35. Now let's factor out the y. So y outside of tan 50 minus tan 35 equals 20 tan 35. And now let's divide that second part in brackets down to the other side of the equation. So y equals 20 tan 35 divided by that bit that I just moved down, tan 50 minus tan 35. Okay, now we are making some progress. So I've just rearranged an equation, or I've used simultaneous equations to figure out what y is. Now I can substitute that back up into this top one. I'm going to choose number 1. So I'm going to have, let me actually just rewrite this equation just so it's a bit easier to see on my OneNote here. I'm just going to rewrite that equation down here. So I've got brackets 20 plus y times tan 35 x. Now before I substitute in this line down here, before I substitute in this one, I'm just going to rearrange the equation that I just wrote just to break it up a little bit. So I'm going to have 20 of tan 35 plus y tan 35 equals x. Now let's substitute in. So maybe I'll write it over here. Now let's substitute in. So instead of y, I'm going to put 20 tan 35 divided by tan 50 minus tan 35. Bit of a complicated one, but let's get through this. So 20, 10, 35 plus, in brackets, instead of y, we're going to put what we figured out y was. So 20, 10, 35 divided by 10, 50 minus 10, 35, close the bracket, times that by 10, 35 equals x. Okay, now let me get my calculator out and let's figure out an answer for this. So 1050 minus 1035 is that 20 times 1035 divided by the answer equals that, times that by 1035 equals that, and now add that to 20, 10, 35, and we get an answer of 33.95. So x equals 33.95. And let's go meters. So that wasn't the question, that was just what x is. So 33.95. Coming back up to here, x is 33.95. Okay, if the total distance is from the tree is 35.5 meters, then the height, and also we're forgetting about Ruka's eyes are located 9 centimeters below the very top of her head. That means that this angle down here actually occurs right at her eye line. It doesn't, my drawing isn't exactly accurate. It occurs actually right at her eye line. So I'm going to have 35.5 minus 33.95 plus 9 centimeters, which is 0.09, equals Ruka's height. And let's figure out an answer for this. So 35.5 minus 33.95 plus 0.09 is 1.64. 1.64 meters. That is how tall Ruka is. Give your answer in meters correct to the nearest centimeter. Okay, bit of a tricky one, but you need to figure out the things that you do know, introduce a few different variables, and rearrange it, substitute it back in, and then solve for the original question.